Hello everyone, let us now start this third topic on our chapter waves. We have already completed our discussion on the basics of wave, the transverse and the longitudinal wave. Let us now understand what are waves and what are wave fronts. Understanding of these two things are very important if you want to solve the exam kind of questions. So sometimes the student might find it difficult to visualize what are wavelength. So if you are going through this problem, this video will answer all your questions. You'll never have any doubts on the difference between waves and wavefronts. So let us start. So what do you see on the picture here? You see a wave, right? You see a wave. It is seem to be coming from a light bulb. So does the light bulb produce only one wave? Think about it. No, it is producing a lot of waves, right? A lot of waves are coming out from the light bulb. Let us draw a couple of them. We are not going to draw the infinite number of waves which are coming from the light bulb. Let us draw a few of them. So here I have drawn 5 waves which are coming out from the light bulb, right? They are kind of in a bunch. There is a pattern between them. They look alike, right? They are traveling in parallel, and that's what happens in actual. So the waves which originate from a source, they actually travel in parallel. If you look at the curves of these waves, they are moving in parallel. All right. So the set of waves here that you see here, that's your wave. So where is the wave front? The question is, where is the wave front? Now imagine, wave fronts are imaginary lines. You need to understand, wave is something which is actual. Wave fronts are imaginary lines, right? So the lines that you see here, the 5 curves, the 5 sinusoidal pattern that you see here, they are your actual waves. If you say that if you are drawing an imaginary line which is joining all the crest means the wave peaks. Imaginary line which is joining all the crest. Imaginary line which is joining all the crest. That is your wave front. Alright, so please do remember that waves are the actual thing. So the white lines that you see here are the actual waves which are moving out, and the waves actually move this way. A light wave is a transverse wave and it would move in a sinusoidal pattern. But what are wave fronts? Wave fronts are imaginary lines. That's your wave front, that's your wave front, and that's your wave front. The yellow lines that you see on the screen, they are your wave front. Alright, wave front are imaginary line which joins all the wave peaks. What is the distance between peak to peak? What is the distance between peak to peak called? Think about it and answer this. The distance between peak to peak is one wavelength. Distance between peak to peak we know is one wavelength. Peak to peak is one wavelength. So what can you say about the distances between two consecutive wave fronts? The distance between two consecutive wavefront is one wavelength. Two consecutive wavefront means two wavefronts which are next to each other. So if you look here, wavefront 1 and wavefront 2, they are next to each other. So the distance between consecutive wavefront is one wavelength, because wavefronts are imaginary line which joins the crest. Crest to crest is one wavelength. Similarly, if you see the second wavefront and the third wavefront, they are consecutive wavefront next to each other. The distance between them will be one wavelength. Alright. So notes, take out your notebooks, take out your pens and please copy some notes. Wavefronts are equidistant lines. Wavefronts are equidistant lines, and you can also say they are equidistant imaginary lines. Second point, the distance between the consecutive wavefronts is equal to 1 wavelength or lambda. Alright, so these are some important things that you need to understand. You should be very clear now about what is a wavefront. You might find it difficult to visualize what is a wavefront. Why? Because wavefronts are actually imaginary lines. Now you can imagine those lines. Now that you have seen what we have on the screen, you should find it easy to imagine. Still, if you are not clear what is a wavefront, let me make your imagination more easy by taking it up other way around. Right? Let's do something more, some more experiments with our imaginations. Suppose that you are given the wavefronts. Suppose that you are given a set of wavefronts. If you are given the wavefronts, then how do you imagine the wave would look like in this space? So you see a lot of space, right? You are just given the imaginary lines which are the wavefronts. So how do you visualize how the wave in this space would look like? Will it look something like this? Or something like this? How would the wave look like? How do you imagine the wave would look like? I am just making you comfortable thinking about this particular point from various perspectives, so that your imagination, your thinking, your processing about wavefronts become strong and you never forget it. So how do you imagine the waves in this set of space look like? That's how. A wave which has a peak on the wavefront goes down, and the peak again comes on the wavefront, goes down, peak again comes on the wavefront, goes down, so on and so forth for each and every set of parallel waves. Alright. Second thing now. Drawing the waves as a zigzag pattern all the time is a tedious task. Usually, how do you represent light? If you look around the light bulb also, how do you represent light or any wave? Usually, you represent wave as a straight line. Usually, you represent wave as a straight line. So how do you represent the wave? Instead of drawing all these zigzag patterns, you can simply draw and say that my wave is going left to right. Instead of drawing the zigzag pattern going from left to right, which can be a tedious process, but your mind knows the imagination of it correctly now. So let us simplify it. Let us not draw the zigzag line all the time. Let us say that the light wave which is coming out from this bulb is going straight away like this. The wave, the white straight line that you see here, it is a simplified version of drawing the zigzag lines. We are not getting into zigzag lines anymore. It is a tedious process. Instead, we are drawing a solid white line here. So what is the relationship that you see here between the wavefront and the waves? So note for the students, please write it in your notebooks. The wavefronts, which are the imaginary lines, are actually perpendicular to the wave. Can you see it? If the wave is moving left to right, the wavefronts are perpendicular to the wave. Make sense? So whenever you are given a wave, you know that the wavefronts would be imaginary perpendicular lines to the wave, and these wavefronts should be equidistant. The distance spacing between the wavefront should be lambda. All these things should come out clearly in your visualization now. The next video is going to be about the reflection and the refraction of wavefronts. We are not talking about wave here, we are talking about wavefronts.